Hello, Miss Barron here. In this video, I'm going to be going over the first problem in the probability and percent deviation worksheet as an example so that you are able to complete the second problem right here. Oh, I'm sorry, here's the second problem right here, okay? So we'll be going through these first few together. Okay, so what you're going to have is a situation, for instance, where there is a cross between something, in this case, two heterozygous purple flowers. So since they're heterozygous, hetero means different, so their genotype is big F, little f. In this case, it says the recessive form of the trait is white. So if we have a flower that is little f, that's going to be white. But if we have any flower big F, or big F, then those are going to be purple. So the first thing that we're going to do is we are just going to complete that cross, okay? So in this box, we're going to have big F. So that would be a purple flower. In this box, we would have big F, little f. Since the purple is dominant and that big F is present, this would still be a purple flower. Same thing with this guy. But this one, it's little f, so that would be your white flower. So what percent of the offspring are purple? Well, if we look here, these guys are purple, so that's 3 out of 4. Or 75% are purple. And then what percent are white? Well, that white is recessive, which is little f. We only have one of those, so 1 out of 4, or 25%. All right, so that's the first thing that's the first step that you want to take when approaching these probability and percent deviation problems, okay? Just do the cross between the parents and figure out what are the chances. We're just focusing on phenotype here. You know, what are the chances the offspring will be dominant or recessive for whatever trait it may be. Again, the Punnett square, the point of this is to figure out the probability, okay? So this is, you know, we're using this to make a prediction, okay? All right, so let's say that those two flowers that we crossed together, the two heterozygous purple flowers, the big F, little f, let's say they had 160 offspring. We're going to calculate the expected results. Okay, so if they have 160 offspring, how many offspring would we expect to be purple, and how many would we expect to be white? So in order to do that, we're going to take a percentage of that 160. So if I had 160 offspring, and according to my Punnett square results, 75% we expect to be purple. So we're going to multiply this by 75%, right, as that decimal form, okay? So 75%, if we were to write that as a decimal, is 0.75. That's very easy. You could just take 75 and divide it by 100, move the decimal over 2 places, whatever, okay? All right, so I'm going to do, in my calculator here, 160 times 0.75, because we're finding out if we had 160 offspring, what's 75% of that 160? Because according to our Punnett square, that's what we would expect to be purple. So we're going to get 120 we would expect to be purple. Now, the key thing here is the expected results. Now there's actually 2 ways to do the next one for the white offspring. You can easily just do 160 times 25 as a percentage. So 160 times 0.25 would give us 40 white. This is how many of those 160 we would expect to be white. according to our Punnett square. Or we could have easily just taken, well, we know there's 160 offspring. We know that 120 are purple, so the remaining have to be white, which also gives you 40. So there's actually two ways to figure that out. Okay, so the flowers had 160 offspring, and then we used our Punnett square results to figure out how many of those offspring we would expect to be purple, which is the dominant trait in this case, and white, which is the recessive trait in this case. So 120 we would expect to be purple, 40 we expect to be white. Now we're going to go ahead and we're going to fill out the chart here, okay? All right, so I'm just going to start from left to right. We'll get to this in a second. So number of flowers, 160. And right now I can fill out the expected results, which is what I got up here from using my Punnett square. So 120 we expect to be purple, which is big F or big F little f. And then 40 we expect to be white. All right, so we're getting those expected results. We're getting the expected, right? We're getting that from our Punnett square calculation. Now they actually are going, the observed is the actual results, okay? So how many of those 160 offspring were purple and white? So this is what actually happened in reality. Remember, this is a prediction, okay? This is a prediction. This is the probability. So what we actually observed, the actual results were 115 were purple. So I'm going to write 115 here. Okay, that's what actually happened. And then 45, so the observed 45 were actually white. So now we're going to find the percent deviation. So percent deviation is like how much did we deviate from that expected result. So in order to do that, so the difference is just simply the difference between these two values. So 120 minus 115 will give us 5. And then you're taking the absolute value, okay? You should not have negatives in any of these results. And so the difference between 40 and 45 is also 5. Both of these numbers should actually be the same, okay? If they're not, then that means that you did something wrong, most likely with these calculations here, with your expected. Now we are going to use this formula, okay? We're going to use this formula here to find the percent deviation. So how much did we deviate from those expected results? So the percent deviation is going to be the sum of the differences. So the differences, that's 5 and 5, and the sum of them. So we're going to add them together. So 5 plus 5, divided by total occurrences. Well, total occurrences, that's how many flowers or how many offspring that we had. So that's 160. And then we want to get that into a percentage, so we're going to multiply that by 100. So we're going to do 5 plus 5, which is 10. 5 plus 5 is 10, divided by 160. And then I'm going to multiply that by 100. So we get 6.25. So 6.25 would be my percent deviation. That would be, you know, the final answer, the main thing that I'm looking for. That's not bad. Usually we would like to have below 5%, okay? It's a little high, so we're a little bit more out of the expected range than what we thought. Okay, so that is how to do a percent deviation problem. And then there's one down here with the same setup that you can complete on your own.